In this tutorial, we'll create an AI-controlled archer that can detect targets, aim accurately, and fire arrows using the same dynamic archery system we've built for the player. We'll cover everything from AI perception setup and target acquisition to handling animation and arrow spawning. By the end, you'll have a fully functional enemy archer that reacts to the player and uses biomechanics just like a real opponent. We're going to start by creating the archer behavior tree. As always, add a selector node beneath the default root node. Then we need to make sure the entire behavior tree only runs while the AI-controlled character is alive. To achieve that, add a new selector with the Actor is Alive custom decorator we created in one of the previous tutorials. Make sure to configure the Actor is Alive decorator as shown in the video. Next, we'll create a branch to handle the attack. The behavior tree should instruct the AI archer to start firing arrows when a target enters its view range. To do that, we'll use a blackboard-based decorator that checks if the archer has line of sight. If you remember from earlier tutorials, we already have logic in the enemy controller blueprint that sets this variable when a character enters the AI actor's sight sense radius. We also need to ensure that the target actor is alive. This will prevent the AI archer from firing arrows at already defeated targets. Next, we'll instruct the AI archer to focus on its target. We'll use the Focus on Target service to handle this. Now we can start firing arrows, but before the character can fire, it needs to aim at a target. To handle this, we'll create two sequences below the selector. One sequence will trigger the aiming ability, and the other will handle the logic for firing arrows. The sequence for triggering the aiming ability should only run if the AI archer is not already aiming. We'll check this by using the Check Gameplay tag decorator we created in the mini-boss tutorial. Be sure to configure the decorator as shown in the video. Now let's create a new task that activates the aiming ability. In this task, we'll override the Execute AI event and call the Aim Start function using the Archer interface. We also need to keep this node active until the AI archer is ready to fire. To do that, override the Receive Tick AI event. On each tick, check if the controlled pawn has the Ready to Fire gameplay tag. This tag is added to the character when they are ready to begin firing arrows. Once the tag is present, call the Finish Execute node and return success. Now let's add this tag in the proper place. It should be applied within the bow and arrow gameplay effect. This effect grants both the fire arrow and draw bowstring abilities. Add a new component for granting gameplay tags and select the Ready to Fire tag. Go back to the behavior tree and call the aim task in the start aiming sequence. Now let's move to the fire sequence. If you remember from previous archery tutorials, we created a dynamic arrow mechanic where arrow speed and velocity are controlled by how far the player pulls the bowstring. All the parameters involved in that calculation are stored on the ranged weapon, making the system highly configurable. The AI archer will use the same mechanic, but will only fire fully charged arrows. First, we need to create a new task responsible for charging. Again, we'll use the archer interface to avoid expensive casting. Following the same pattern as the aim task, we'll check if the arrow is fully charged using a new gameplay tag. Next, we need to assign the fully charged tag to our character at the right moment. Open the bow and arrow draw bowstring ability blueprint. Find the calculate montage play rate function. We're already calculating the time needed to fully charge one arrow. Select those nodes and collapse them into a new function called Calculate Arrow Full Charge Time. Make it a pure function and change its access specifier to protected. Now go to the event graph. At the end of the Activate Ability event, use the new function to delay execution of the Apply Gameplay Effect to Owner function. This ensures we apply the fully charged effect at the correct time, when charging is complete. Next, create a new gameplay effect that grants the fully charged gameplay tag. Promote this effect handle to a variable. We need this reference so we can remove the gameplay effect once the ability ends. Go back to the behavior tree and add the charge task as part of the fire sequence. Now create a task for firing arrows. This one is simple, just override the execute AI event and call the fire function from the Archer interface. After the fire task, add a wait task to pause for 1 second before proceeding. With that, the attacking behavior is complete. Now let's create a branch that handles the state when the AI Archer has no target or the target is defeated. First, we need to make sure the AI Archer exits the aiming state. To do that, use the Check Gameplay tag decorator to ensure this sequence only runs if the Archer is currently aiming. We'll also need a new task that calls the aim-end function via the Archer interface. Be sure to include a 1-second wait task before moving on. At the end, add one more wait task at the far right of this selector. Let's now look at how to use this behavior tree. Create a new Archer controller as a child blueprint of the enemy controller. Override the onPossess event and call the function to run the Archer behavior tree. One advantage of having a separate AI controller for Archer characters is the ability to override AI perception settings. For example, archers could detect targets from farther away than melee characters. To achieve that, change the sight radius and lose sight radius values in the sight sense configuration. Now create a separate blueprint for the Archer enemy character as a child of the enemy blueprint. First, replace the AI controller with the Archer controller we just created. Then remove the default weapons from the left and right hands, and add only a bow to the ranged slot. Next, implement the Calculate Arrow Velocity function. This was defined in the Archer interface but was only implemented for the player blueprint until now. First, check if the arrow reference is valid. Then add a sequence node. First, get the max projectile speed from the equipped ranged weapon using the Weapons Ability System component. Next, calculate arrow velocity. Use the Predict Projectile Velocity function, just like in the player blueprint. This time, use the target actor from the blackboard as the end location, and the max arrow speed as the launch speed. Make sure to enable the Accept Closest on No Solutions option. Now we're ready to test the AI-controlled Archer. Add an instance to the map and run the game. As you can see, once the player enters the archer's view range, the archer starts aiming and firing arrows. However, there's one issue: if you damage the archer while they're drawing the bowstring, they'll stop firing arrows permanently. This happens because the hit reaction animation interrupts the charging ability. There are multiple ways to fix this, but we'll use a common and simple solution: prevent the hit reaction montage from playing while the character is aiming. If you recall from the mini-boss tutorial, we already implemented this using the damage ignore reaction gameplay tag. Let's use it while the aiming ability is active. Open the bow and arrow aim ability blueprint. In the class defaults panel, find the activation own tag section and add the damage ignore reaction tag. This ensures that no damage reaction montage plays while the aiming ability is active. Let's test it now. As you can see, when the archer is hit, damage is applied and health decreases, but the hit reaction montage is ignored, just as intended. The same applies to the player. Once they're in the aiming state, no damage reaction montage plays. This can be improved further by adding a posture or stance breaking mechanic that triggers a reaction animation when the character's posture breaks. But we'll stop here and leave that topic for a future tutorial. Now we're going to implement a common archer behavior found in most games: keeping a safe distance from the target. This behavior ensures the archer finds a new location and moves to it when the target gets too close. To constantly monitor the distance to its target, we'll add the set distance to target service. Make sure to configure it as shown in the video. Next, we're going to add a new selector between the start aiming and fire sequences. We also need to add a decorator to ensure this branch only executes when the target is within melee range. To find a new safe location, we'll use the environment query system. Create a new environment query and add a simple grid generator. Be sure to configure the generator as shown in the video. Next, add a test that ensures a path exists from the querier to the new location. This test should only filter points, so make sure to set the test purpose to filter only. Now we need to ensure there's visibility between the new location and the target actor. To do that, we'll add a trace test. As before, this test should only filter points. Configure the trace to use the camera channel, and instead of a line trace, use a sphere trace with a radius of 25. Lastly, add a distance test. This test ensures the distance between the new location and the target is within 800 to 1000 engine units. Now go back to the Archer behavior tree. Use the environment query we just created to set a new location. Make sure to configure it to select a single random item from the best 5%. Also, disable update blackboard value on fail. If you want the Archer to fire arrows while moving, you'll need to use a simple parallel node here. Be sure to set the parallel node to delayed mode. Then, add a task to move to the new location as the main task. For the secondary task, simply copy the fire sequence. Let's run the game and test this now. As you can see, once the player gets close, the Archer starts moving away, maintaining a safe distance. And while moving, the Archer continues to fire arrows, making it harder to defeat. One last thing I'd like to cover in this tutorial is enabling the AI Archer to react to damage events. Right now, if you sneak behind the enemy and shoot an arrow, they'll take damage but won't turn toward the attacker or try to defend themselves. Let's fix that. Open the enemy controller blueprint. Select the AI perception component and add a new sense to it. Choose damage sense and set its max age to 1 second. This ensures the sense stimulus expires after 1 second. Now we need to refactor the on-target perception updated event. Currently, it only handles the sight sense. We'll extend it to handle damage sense as well. First, create a new custom event for sight sense, and move all existing nodes from on-target perception updated into it. Then create another custom event for damage sense. In this event, make sure the stimulated sense is of type AI damage sense. Also check that the sense was successfully stimulated. Next, set a Boolean Blackboard variable named as damage to true. Also, save the actor that triggered the damage as a new Blackboard variable named attacker actor. Now make sure to add both of these variables to the Blackboard. When adding attacker actor, be sure to select actor as the base class. Return to the enemy controller. We need to make sure as damaged is reset to false, and attacker actor reference is cleared once the damage event expires. Finally, call the new custom events from the end of the on-target perception updated event. Now open the Archer controller. You may notice that the damage sense is not inherited from the enemy controller. That's because we overrode the site sense config. To fix this, just undo the override for the sense config, then reapply the changes for site radius. Now we need to send the damage event when the character takes damage. The best place to do this is in the NPC blueprint. Override the on health changed event. First, make sure to call the parent implementation. Then check if the delta value is negative, and call report damage event to notify the AI damage sense. Now open the Archer behavior tree. We're going to add a new sequence between the two main branches. Add a blackboard decorator to this sequence that checks if a damage event has been received. As part of this sequence, add a task to rotate the AI Archer to face the attacker actor. Once the rotation is finished, the attacker will enter the Archer's view range and the attack branch will begin executing. Also, make sure to set this decorator to abort lower priority nodes. Let's test this. As you can see, the Archer now rotates to face the attacker when a damage event is received. That wraps up our AI Archer tutorial. We've covered everything from setting up a complete behavior tree to making the Archer keep a safe distance, fire charged arrows, and react dynamically to incoming damage. If you found this tutorial helpful, consider liking the video and subscribing for more deep dive Unreal tutorials. Special thanks for my Patreon supporters. Thanks for watching, and I'll see you in the next one.